Okay, so the first problem that I will be working on is if 7.96 times 10 to the power of 20 molecules of CO2 are produced in a combustion reaction, what is the volume in liters of CO2 produced? And we are also given the density of CO2, which is 1.98 kilograms over meters cubed. So first, we're going to want to identify what we are looking for. So right here it says volume in liters of CO2 produced. The other important piece of information we are given, just starting out, is the 7.96 times 10 to the power of 20 molecules of CO2. So to help us get started, I'm just going to write how many liters CO2 are equal to 7.96 times 10 to the power of 20 molecules CO2. Okay, so now that we have that clearly written, I'm going to go ahead and write a roadmap. So we are going to start with the 7.96 again. And we know that to convert eventually into liters, we are going to have to first convert this into moles. And we will do this using Avogadro's number. And then from moles, we are going to use the molar mass. I'm going to do mm to represent that, to convert it into grams of CO2. And eventually we will have to use the density that is listed, the 0.98 kilograms per meters cubed. So I'm going to go ahead and convert the grams to kilograms. And then using that density equation, we're going to get into meters cubed. This is where it gets a little bit tricky. I know that centimeters cubed equals, let's say 1 centimeters cubed, is equal to 1 milliliter. And since we eventually want to end up in meters or liters, I'm going to use this conversion factor in order to get there. So meters cubed of CO2 to centimeters cubed to, let me go ahead and just move this over. Oops. So going from centimeters cubed into milliliters. And then finally into liters. So I'm going to go ahead and set up a table so that we can do this equation, starting with our molecules. Okay, so we're going to write that just up here. Making sure to include units, as then you can see it more clearly cancel out. So this is where we're going to use Avogadro's number. Sometimes it's easy to think that that is only for atoms, but it is for atoms and molecules. So that is 6.022 times 10 to the power of 23. And we're going to make sure to include our unit, molecules of CO2. and that is in 1 mole of CO2. Sometimes it's easy to get mixed up with the units mole and molecule, which is why I always try to include the C at the end of molecule. So then we're going to have these molecules cancel out, and now we are in moles. So to convert from moles to grams, you're going to want to calculate the molar mass of CO2. So taking 16 plus 16 plus 12.01 will give you the molar mass, which is 4,401 grams of carbon dioxide in 1 mole carbon dioxide. The moles cancel out once again, and now it is time to convert into kilograms. So we know that there are 1,000 grams in 1 kilogram. And it's always helpful to think about the bigger unit is typically the smaller number. There's more of the smaller unit in 1 big unit. So now that we have it in kilograms, we are going to go ahead. Okay, so we are going to use the density from before to convert this into meters cubed. So that is, let me get my pencil, 1.98 kilograms in 1 meter cubed. Okay, and since we know how to convert from meters cubed to centimeters, that's what we're going to do here. We also don't want to forget to still be using our units here. Okay. So we know that in 1 meter cubed, there are 1,000 centimeters cubed. And we don't want to forget, sorry, I just mistyped that when the centimeters is cubed, so is the 1,000. In the meters, when it's cubed, there's also a cube on the 1, but it doesn't really do anything because it's a 1. So now we're going to do our conversion factor that we know. To bring it into milliliters. And we also know that in 1,000 milliliters, there is 1 whole liter. So I'm going to go ahead and quickly calculate this out. But before that, I'm going to make sure that all my units are canceling. So we have grams canceling, kilograms canceling, meters cubed canceling, centimeters cubed canceling, and finally milliliters canceling, leaving us with liters. So after calculating 2.94 times 10 to the negative 2 liters CO2. We're going to box that in just to make it stick out and make sure that our sig figs are correct. So there is 1, 2, 3 sig figs here, and 1, 2, 3 sig figs here. And in our answer, we have 1, 2, 3 sig figs. So this one should be good to go.